Okay, everyone, welcome to the EP3 AI Integration Webinar. I'd like to thank you for joining us today. My name is Karen Walkerman. I'm the primary developer of EP3. And I guess we can just get started here. Just give me a moment. Okay, so this is the EP3 AI Integration. Oops, that is the end of the slideshow. Let's go back to the beginning. Here we go. This is the EP3 AI Integration Webinar. And before we get started talking about AI, I'd like to give you a little bit of introduction to myself and to EP3. So my name is Karen Walkerman. I have about 15 years of experience modeling with Energy Plus. I've been a contributing developer to Energy Plus, and I'm the primary developer of EP3. There's some driving development philosophy behind EP3 that kind of shapes everything that we do with EP3. That is that each modeling project should require only one file. We wanted to be able to create all of the efficiency measures in one file and handle them within one file. We want to leverage the power of SketchUp to make drawing building geometry easy. Edits should be able to be made at any stage of the project, and they should be easy to make at any stage. HVAC system connections are made and displayed in a graphical user interface. And we wanted to just expose the Energy Plus structure, not hide it. We wanted to expose it so it's easy to understand. Computers should be doing the things that are easy for computers to do and leave modelers free to do the more complex analysis. And also importing Energy Plus files is just as important as exporting Energy Plus files. So how does EP3 work with different project phases? So, we have schematic design, and then we go to design development, and, we have some refinements to the building geometry. We have construction drawing level. We might have value engineering stuff that happens. And then we have an as-built model, which is often used for compliance or green building certification. And then we may have calibration models. And the as-built models over here, this is generally where the budgets are for doing energy simulation. So it's compliance rating models or incentive models. But our impact as building energy simulation professionals, it usually happens all the way over here. The goal with EP3 was to be able to start a project in SD and have that model grow and adjust with the project. So what if we can provide consistent model alternatives and feedback as that project develops? So here is a simple schematic design model. This model takes just a minute or two to set up. You can simulate HVAC system alternatives in the same model, and those alternatives are actually generated by the wizard as you use the wizard to set up a schematic design model. And this model will simulate straight from the wizard. So it has all of the different components that you need to run a model and provide your design team with some initial feedback about schematic design level changes. And your model will come out of the wizard with, it's very easy to set up, but your model will come out of the wizard with fully defined and editable HVAC systems, internal loads, constructions, and building geometry. And as the model develops, we can add design details. So here we have on the left, this is an IFC model where we ran an EP3 importer and then translated that building directly into EP3. If your IFC model has spaces defined and named in accordance with your space template and zone template objects in EP3, you can import that model, and what this little video is showing is each of the different space types being highlighted in the building. And this came straight in from the IFC model without any additional work in EP3. And as the design develops, you can add more detail. So here we're looking at the HVAC system and a direct outdoor air system in the HVAC system diagram. And this level where we're adding detail, this is where there's a gap that starts to emerge between beginning modelers and expert Energy Plus modelers. So the beginners are very successful at creating models that use the wizard. They're very successful at refining models by importing templates, and they can generally create or refine building geometry, but they may get stuck understanding the details of their models, implementing some more complex approaches, or troubleshooting models. Whereas the expert users really love having complete control over their Energy Plus models within EP3. So how do we bridge that gap? So one option is to simplify the user interface to make it easier for beginning modelers. And that comes with a couple of compromises. One is that it adds a lot of rigidity, and it also makes it less attractive to expert users. So every time you add a layer of simplification or obfuscation, it makes it more difficult to do things like import existing Energy Plus files. It makes it more difficult to have access to all of those little details that really make Energy Plus a very powerful software. We can also bridge that gap by providing training, which has been, training and mentorship has been the hallmark of getting beginner modelers to expert modelers. But this last one, excuse me. This last one here, the careful implementation of AI support. This is where we initially conceptualized having an AI integration within EP3 was a way to provide beginner modelers access to some of the more complex aspects of Energy Plus in a structured environment, and to help them supplement training and the simplifications that we provide within the user interface. So let's take a step back away from EP3 for a moment and just discuss AI in building energy simulation in general. So in general, there's two AI approaches. We have our black box models. Those are data-driven models. They simulate building energy performance without explicit physical models. They can be very, very fast, but they're less transparent. So that might be appropriate for some level of compliance modeling or studies, large-scale studies where the specifics of an individual building may be less important. You're trying to answer some general questions about a region, perhaps. But they do not excel when you need to model something new or different. They work when the building that you're modeling falls within the parameters, sort of inside the parameters of the training data it was given. So approach number 2 is using AI to generate or modify input files to leverage existing physics-based simulation engines. So the file, this allows the creation of a verifiable model. And all of the Energy Plus MCP and the Energy Plus AI integrations that we've seen over the past couple months, those use the second approach. And that's what we're doing with EP3, is using AI to help us create the EP3 model, which then uses the Energy Plus engine. So I won't go through these in detail, but I just want to call out that there are so many Energy Plus AI projects going on right now. Like Energy Plus MCP has gotten a lot of interest lately. I've used it a little bit. It's very impressive. There's another project out of LBNL that's a dynamic multi-agent network that's very impressive. Anyway, I will leave these up here. If you would like to go back and watch the recording and hit pause and read about these a little bit more, you're more than welcome. Okay, so EP3 and AI models in practice. We're implementing Anthropic's Claude LLMs for enhanced simulation workflows. We've had really good results with Sonnet 4.5 and Haiku 4.5. And we have AI assisting with error checking and resolution, understanding the model, visualizing data, generating reports, and modifying the EP3 model. I'll show you, so I'll demonstrate some of this, so I won't go into this in detail. We have some model and data protections. Data protection is one of the reasons why we chose Claude's, or the Anthropic's Claude's model, is because we felt that that company had some of the best data protection promises in their end user agreement. But EP3, once the data goes out to the Claude models, we can't take any responsibility for exactly how Anthropic chooses to use that data. Each EP3 user who's using the AI integration will need to have their own Anthropic API key, and they will have their own contract with Anthropic about how their data is being used. So that's kind of the data security section. The model integrity section, so these are the things that we can do in EP3 to make sure that the information that we're getting from the AI agent is valid and is doing the right thing for your model. So one thing is that the AI agent is not allowed to make any changes to your model without your approval. If you ask it to modify your model, it will then provide suggestions, and you can integrate them or reject them with a button click. We also recommend saving a backup copy of your model prior to making changes. You can make one change at a time and test to make sure that those changes are having the effect that you want. And then also, this is one thing that we do internally with EP3, is that you can create an efficiency measure where you can make your AI changes, and those changes are kind of siloed from the rest of your model. So it's another way to sort of protect your base global model from anything that's happening with the AI. So right now we're calling the EP3 AI Integration Atlas. It's provided with context. So here we see the EP3 view for a schedule, and I have a schedule selected and clicked on the AI button here, and it says, "Hello, I'm your AI assistant for all things EP3 and Energy Plus. How can I help you today?" And you can see that it is looking at this schedule, and we show it at the moment. We're showing it in Energy Plus format to you. If you have no object selected, you can ask general questions about your model. So here is an example of some of the things that the agent came up with when I said very lazily, "Tell me about this model." So as you may know, when working with AI, the better your prompt is, the better your response. So this "tell me about this model" is quite lazy, but it does show you some of the process that's happening in the background. So it says, working on your request, it's going to access model information, some tools, and it's going to go in and get some information from the model. And then it gives this overview, which is pretty good. It gives a summary of the different floors, which zones there are, zone characteristics. It recognizes the types of spaces in the building and HVAC systems. So it gives us kind of a general information about what's happening. So this sort of thing can be very useful if you're using EP3 to look at a model that was generated by somebody else. EP3 can also import complete Energy Plus files that were completed or created elsewhere. So one workflow that we have some users doing is they are generating complete Energy Plus files using some other AI. And then when it comes time to interact with the model, they're bringing it into EP3. So one of the things about these other Energy Plus AI project is that, as far as I know, they're sort of mostly working directly with the Energy Plus files and not inside a user interface. Eventually, maybe we'll move away from user interfaces in general, but at this point in time, I think it's very important as a modeler working on an actual building to have to have a complete model that is cohesive, where you can inspect different aspects of the model. You can take a look at the building geometry, you can visualize the HVAC systems, and you can also make your own changes in your kind of in your own way. I sometimes use AI to help me write articles, or sort of flush out ideas. Sometimes I have a very technical thing that I want to say, and I'm saying it in one sentence, but most people need a little bit more explanation, and I'll use AI to help me create that. But there comes a point with editing with AI where you say, make this change, and it will not make that particular change. So that's a place where it's helpful to have an actual user interface for Energy Plus, or I'm sorry, an actual user interface where you can see and work with your model so that you can create the changes that you want to create on your own. Okay, so here's a more specific example. So in this case, we're going to use the AI to understand and modify some boiler operation. So this is the HVAC system diagram. Here we have a chilled water loop, a hot water loop, and then we have our central plant for the hot water loop. And I've just clicked on the boiler here. And you can see the information about the boiler in the selected object dialog. And I've clicked on the AI button. And I'm just asking it, is this an efficient boiler? So now it's going to work on the request. And it's pulling up some information and some perspective. So this is one of the things where there's been some discussion about using AI with Energy Plus. When is it useful to use a large language model? When is it useful to use a small or medium language model? We've had pretty good success with the large language models when we give it some specific parameters. And asking it, is this an efficient boiler? This is a question that a small language model would not necessarily have the perspective to provide the sort of context for that sort of request. So it's given a whole bunch of information about the efficiency of the boiler, and then I've asked it to make some changes to make it more efficient. So it's suggesting some changes. It's suggesting changing the nominal thermal efficiency, and it's suggesting a new boiler curve. And I can say integrate or reject. And then if I click on the boiler again, I can see those updated values. So we can also use it to take a look at some more complex requests. So in this case, we're using it to understand and modify entire HVAC configuration and operation. So in this case, I'm going to select the entire HVAC systems. And again, click on the I button, and it's saying, I understand you have questions about these objects, and it's a much, much longer list of objects here. So my question is, in this particular case, how is ventilation air provided? And this is one of those things that, as someone who's used Energy Plus for 15 years, ventilation controls can be a little bit challenging in Energy Plus. Understanding which equipment is providing ventilation, how is that controlled? Is ventilation provided by zone HVAC units? Is it provided by an air handler? So using the AI to understand this was a big test for us. Can it answer this sort of a question? Because this is a question that I think a lot of modelers will have about a lot of different models. And it's done a pretty good job. It's identified that there's a dedicated outdoor air system. It's that's 100% outdoor air. And then it's identified that there are some VRF units and some 4-pipe fan coil units. So now I want to make sure that those fan coils are not providing any outdoor air. Instead, we're not really sure if it's providing outdoor air. I think it's correct that the fan coils may be providing outdoor air. And so I've asked it to help me ensure that the fan coil does not provide ventilation air. And it's taking a little bit of time, but now it's come up with some edits to the fan coil object, which is setting the outdoor air values at 0. And again, I can integrate or reject these suggestions. We can also use the AI to provide data visualization and system operation description. It's quite good at understanding curves and providing graphs, that sort of thing. So in this case, I have selected a variable refrigerant flow air conditioner. And you can see up on the left, I've also chosen a different model. You can switch between any of the available Anthropic models at any point in time. And the prompt down here is provide graphs of each of the curves that govern efficiency and capacity of this VRV, and also provide a description of how each one controls performance and capacity. So in the background, it's taking a look at what curves were referenced by this object, going to get those curves, collecting data, and it's now creating the visualization. So there are a lot of curves which govern VRV operation, but here they are. And on the left, it's starting to build up this description to provide some context for what each of these curves do. Whenever the AI creates curves like this, we have the option to save all of these curves, either individual curves or save all of them as images. And the intent behind that is you can go and pull these into reports if you want to add some detail to a report about equipment operation or any sort of data visualization. You can ask the AI to create that data visualization and then save those reports as images and reference those images in your reports. We are also using Atlas to analyze and resolve simulation errors. So in the background, this file is one of the Energy Plus example files that we imported into EP3. It's the 5-zone air-cooled example file. And when we run it and simulate it, we get a some sort of an error. So when we create when we simulate and we create results, so right now we just have one efficiency measure that's being simulated. And up on the right, we can see there's a list of all of the efficiency measures that were simulated. Global is what we call the sort of global model. That's where everything kind of lives in your EP3 model. And then as you add efficiency measures, they will get different names. But next to each efficiency measure that was simulated, there'll either be a green check if there were no errors, a yellow check if there were errors, but it simulated anyway, and then a red X if there were any severe errors. So if you click on this button here, it will open the error file and show it to you. And the AI agent is available to help you understand those errors. So I'm asking it to help me understand and resolve the severe error. So in this case, there's just one. It's a great example to share, but it's identifying the severe error, and it's going and actually looked at the model to figure out why that error is being created. And it's suggesting an improvement or a modification to resolve this error. And we can see here, this is the object that it modified. So now I will simulate the file again. And we can see that the error was resolved in this case. Okay, so I'm going to move out of presentation mode here for a second. So we can also use AI to generate reports. And let's see. So this is a I just want to say also, there are some questions coming in, and I will address them at the end. And yeah, so keep typing questions in as you see them, and I will absolutely address these questions. We'll have a bunch of time for questions and answers at the end. Okay, so on our screen here, this is a model that was created using the wizard. So this is like a schematic design wizard. You may recognize this from the screenshot of the schematic design modeling. And in this model, I created 4 different efficiency measures that I want to simulate. So some of them were created automatically by the wizard. Now, I don't really have time to show everyone the wizard in this particular presentation. However, when you create a model in the wizard, you can bring in multiple complete HVAC systems. Every time you bring in a complete HVAC system, the model automatically creates an efficiency measure so that you can model just that HVAC system. So here we have a list of our different efficiency measures. And if we have time at the end and you're curious, I can show you a little bit more about how efficiency measures work in EP3. But there are 4 right here that I've simulated. So there's a fan coil efficiency measure, a VRV efficiency measure, and then I've also combined those 2 HVAC system options with a low-powered lighting power density measure. And if I look at view results, this is the EP3 results viewer, and we already have some very good data visualizations and tables. So this is the table that most people are most interested in, combined with total annual building utility use or utility cost. But we have our 4 different efficiency measures, end use energy. We have some graphs. You can choose different types of graphs. But up here we have a button that says generate a report with AI. And this is basically a structured way to provide prompts to the AI to generate a report for you. There's a section for writing style. So you may say something about who your audience is, what type of language you want to use. Do you want it to be verbose or very brief? Then we have a CSS style section. So this section may improve in the future, but at the moment, the report generator is generating an HTML document, and the CSS style is how it knows, or the CSS style gets applied later and tells it what font to use, colors for tables, all kinds of different formatting types of things. Then we have a section for relevant project data. So this would be your project name, who you are, your name, your company, who you prepared it for, anything else that you want to go in a header on your document. And then we have sections. So this is a definition for a relatively detailed report. We have an introduction section, then we have input summaries, where we have subsections as well. So we want to know about the building envelope. We want to know about internal loads, HVAC systems, utility rates, unmet hours, and then there's results and conclusion. The other thing we've done is we've provided this option to write the section last with context. So the AI is writing each section kind of in order. But if you click write last with context, when the AI, we'll wait to have the AI write this section until the end, and we'll give you what it's written for all the other sections along with it. So that's generally, I use that for results and for the introduction, because it can be quite helpful for those two sections to have some additional context and information about the rest of the report. We can also load, you can save all of this. So once you go through the process of creating all of these details, you can go down here, you can either generate a report or you can save the report structure for later. And once it's saved, you can load the instructions as well. So right now I have two different report structures created. So I have a standard report, which is essentially what we're looking at. And then there's a simple report where there are some differences. So here I've changed the writing style a little bit. So the beginning is the same. It's a technical report intended for an educated audience. Use clear, direct language. But I've also said this report is intended to compare potential design alternatives and should be concise and easy to read. It should provide relevant information without overloading the reader with inconsequential details. So I'm going for like a couple-page report that somebody is actually going to read versus a 20-page document that they're going to have some other AI summarize. The sections are a little bit more brief. So I have the introduction section, but the input summary is sort of a combination. I still have those same subsections, but I'm providing it in the same place. And the hope is that this entire input summary section, by doing it this way, will be a little bit smaller, a little bit shorter. And then you can say generate report. So I'm not actually going to click generate report because it takes a little while for the AI to actually do all of the thinking. But if you give me just a second, I'll give you a little video of its like thinking process here. So here we go. So as the report is getting generated, we're displaying all of these thinking messages so that you kind of know what's going on and you can see a little bit about what it's doing in the background. And then, let's see. And then this is the report that it generated. So I haven't done anything to this document aside from I've not done anything to it other than pressing go in the in EP3. So we have our report header with a date, and this looks quite nice. It's giving me a list of efficiency measures analyzed. We have a snapshot of the building as well. Some project overview and simulation objectives, an input summary, internal load summary. So it's following the structure that we gave it. HVAC system description, utility rates, unmet hours, site and source energy, and it's giving us a graph of building utility use and also cost down here. So it's pretty complete. If you go through, you can find some little places where maybe it was a little bit lazy or some minor changes that need to be made. But this is a huge step up to kind of have a first draft of your reports. The other thing that you can do is that if you remember, so we had this model here. And in the slides, I showed you how you can import IFC geometry and keep going with the same model. So if we were to take, this is the model with the IFC geometry, we could generate the same report just by loading in that new report definition and clicking go. There's also, this is sort of the longer report format on this schematic design model. So you can see instead of being, it's up to 12 pages instead of being a little bit shorter. But again, pretty good structure, accurate data collection. Conclusions are pretty good. I mean, I think I could have used this for years. Okay, so now I'm going to open it up to questions. I'll give you all just a couple moments to type some questions into the chat, though. Okay, so we had a question about the Energy Plus MCP. How was it impressive? The Energy Plus MCP can load in, understand, modify Energy Plus files on its own. It can simulate them. So you can run a query such as provide a study that compares code minimum insulation levels to 20% improvement, based on this base model, and write a report. You can kind of provide that all in one query, and it actually does a pretty good job with all of it. I think the limitations, like I said, is that there isn't a particularly good way to inspect the changes that agent makes to your base file, and it has the sort of typical issues that you might have with any sort of document editing with AI, where if it doesn't understand your query, you can kind of get stuck and go around in circles. But to be able to load in an Energy Plus file, have it make some changes without scripting, I think that is really quite impressive. Okay, so the person who asked that question said that they have not been able to achieve that. So we have a question about the capabilities of EP3 in regards to automatic geometry creation. So from non-structured data, so 2D drawings, project specs, etc. We can take a 2D floor plan and generate an EP3 floor from it. The quality of the output that you're going to get is dependent a little bit on the quality of that 2D floor plan. So that would be like a DWG or DXF file. It depends a little bit on the quality of the floor plan. I've seen some other tools where they say, hey, you can import a DXF and we automatically generate a floor plan based off of it. But those tools, they're not the architectural DXFs. They're DXFs that are created specifically for importing into energy simulation files. So actually, I can show you. Let me see. I can do a little quick demo. Well, I'll show you. I don't have one that I know where it is that I'm allowed to share publicly at the moment, but you can also trace over a drawing. So I'm showing you this because this is if you don't have a high quality DWG or DXF, you can also very quickly trace over any sort of image and create a floor with it. So here I can say add a floor. And you can very quickly create your spaces in this process of kind of adding and removing geometry. So there's no like, oh, I can't subdivide that space. You can just really draw quite quickly. I usually get the outline of the entire building and then go in and subdivide. Okay, so I have already in that real quick amount of time, I have my 4 apartment zones, a central circulation space created off of it, an image. Okay. We have some questions about compliance software. Our highest priority as far as compliance is the lead baseline generator, which is about 40% complete. We also have a number of customers in Southeast Asia who are waiting for a green mark compliance automatic generator. So those are our top priorities at the moment. And I don't see doing the state of Florida compliance software at the moment, but if we had enough customers, we could consider it. Let's see, there are also some questions about EP3 pricing. There's a contact form on our website where if you can fill out the contact form and let us know if you are a commercial enterprise or a graduate researcher or a professor with students. We have pricing for the 3 different user groups. Go ahead and fill out the contact form, and we'd be happy to let you know. So, okay, we have a question about the top 5 on the new development roadmap. So the top 5 are a couple of questions about ASHRAE 90.1. So yeah, ASHRAE 90.1 Appendix G is, I would say that's number 1 on the top 5 for new development. It was the number 1, and then we started playing around with the AI integration and realized that the ASHRAE 90.1 Appendix G baseline generation will go a little bit faster if people have the AI tool enabled. We can rely on AI to kind of help us in those baseline model generations. There's a question about if there's an additional cost for using the AI tool. At the moment, there is not an additional cost from EP3. I will say that it's in beta mode, so we're looking for you to provide us with we'd love to have a little bit of feedback about how you're using the AI integration. Give us some feedback. Is the report generator doing what you want? Are there times when it's doing something unexpected? Are there ways that you love it? So when it comes out of beta mode, we don't have a plan to charge extra for it. The additional cost is that you need to have an Anthropic API key. And so the more you use it, the more you will get charged by Anthropic for your data. That said, one of the reasons we went with Anthropic is because the minimum amount that you need to spend to get an Anthropic key is just over $5. At $5, you have pretty restricted data, but once you spend $40, and it's not $40 per month, it's like lifetime $40, you have quite good data use. So yes, you will incur additional fees for using the AI tool, but I would be surprised if they're high. I think, I would guess 20 to 40 bucks a month if you're using it a lot in EP3. Another question about plans for ASHRAE 90.1 and California Title 24 compliance models. Definitely, yes, the ASHRAE 90.1 is coming. California Title 24, don't have plans for that at the moment. Let's see. I think we do have another question about the efficiency measures. So I'd like to show a little bit about how efficiency measures work in EP3. So if we go to the HVAC system diagram, let me get rid of this background here. If we go to the HVAC system diagram, right now we're in the global model and we can see that we have a whole bunch of different plant components. We have a lot of stuff in here. And if we select so let's just identify some of these. So we have the DOAS system, a hot water loop, a chilled water loop, and a condenser water loop. If we scroll down, we can see these zone HVAC systems. So the fan coil, the DOAS air terminal unit, baseboard, and we have this VRF object here. So keep an eye on these VRF objects. If I switch to the fan coil EEM, those VRF objects, those objects associated with the VRF efficiency measure disappear. And if I go to the VRF efficiency measure, those objects come back. So this holds all across EP3. And if we go to the space template, where we can see we have lighting objects, in the global model, all of these inputs have a background that's in white. So anytime in EP3 you see a background that's white, that tells you that this particular piece of data is stored in this location in the model. If we go to our LPD measure, we can see that all of these backgrounds have changed color to a pink color. And that means that those values are all inherited. I can scroll over and see that my lighting power density is white. And so that's actually a value that is stored in this location in this efficiency measure. I actually created this efficiency measure with the AI. So what I did was I first created this measure called LPD reduction, and then I changed the EEM in EP3 to LPD reduction, and then I asked the AI to reduce the lighting power density by 20% across the building, and it identified the lighting objects, and it it suggested a change that reduced the lighting power density by 20% for each one. So the AI can do some things that in other tools you might need to do with scripting. We had an early request for one of our beta testers who's on the call. And that was related to zone HVAC equipment. So for zone HVAC equipment, we can see that for each fan coil, this fan coil is actually applied to a whole bunch of different zones. And on a real project, maybe not all of these values would be auto-sized. Especially for, well, if you had a something with a DX coil where you had different COPs for different sized equipment, you might want to go in and set values for each individual piece of equipment. So this early tester said, can I import a spreadsheet that just says what those COP values are for a list of different zone terminals? And I haven't forgotten that question. That was about a year ago. And actually the AI can do it. You can give it a list and say, here are the different zone terminal names. Here is the input that I would like to change, and here are the values for each one of those zone terminals. So this is going to allow us to respond sort of more quickly to the request by all of our users. So here we have a list of all of the efficiency measures. I apologize, I went off topic a little bit with the user request with being able to update zone HVAC based on user requests. So I have a bunch of different efficiency measures listed here, and we can combine them and sort of change them around with some of these buttons here. So we can change the name of EEMs. We can change the order in which they're displayed. So we see here, I have fan coil VRV, fan coil LPD, and VRV LPD. This order is the order that these EEMs are displayed in this list. It's also the order that they are displayed in the results. And it's the order that they're displayed when you use the report generator. So if you want to change the order in which they appear in your reports, you can change them. You can change them in this display order. We can also change, we're calling it changing EEM bases. So you can change which EEMs, you can kind of stack them on top of each other. So you can add multiple EEMs together. So this LPD reduction EEM was created, and then we added the fan coil LPD and VRV LPD include that LPD reduction. So if there are any more questions, let me know. I think we've covered them in a fair amount of detail. I want to thank all of you for joining us today. We showed a lot of information about both EP3 and the EP3 AI integration. Let's see, here we go, so I can see you all. We showed a lot about EP3 and the AI integration. I'm really excited to have your feedback, what you learned, what you liked, what you don't like. One of the things about being a young company is that we're really able to respond to our users and all of your user requests. So let us know what you think, and I look forward to connecting with all of you in the future. Thanks again. Okay, so I'm going to end the call, and I believe we will send a link to this recording. So if you want to revisit anything, you'll get an email with a link to see the recording. Thank you all so much.